So here, suppose we have the LDA system whose impulse response is h of t, and a given input is x of t, the output is y of t. Now here the question is asked, x of t input is given as a step signal, so it is a unit step signal, as we are know, unit step signal u of t, and the output is a exponential decaying function. It is available only on right side of the time domain. So here e power minus at, it is a exponential decaying function. It is available only in the right side. Why? Because means it is multiplied by u of t. It is available only on the right side. So they were asking to find what is the value of output, what is the function value of output for the given input x of t, that is step function, whose impulse response of the system is exponential decaying function. So as we all know, very famous property, convolution property, output of any function is equal to x of t convolved with h of t. Output is equal to x of t convolved with h of t. So this is the formula for convolution. That is the formula for convolution, that is x of t is converted into x of tau, h of t is converted into h of t minus tau, and variable is t tau, and the integrate over the limit minus infinity to plus infinity. So this can be achieved using 5 steps. This integration can be achieved using 5 steps. The first step is change the variable. The given values are, the given functions are x of input function x of t and output function h of t. So first you change the variable, that is t is converted into tau, x of tau, and h of t is converted into h of tau. And the second one is fold the second signal. This is the second signal. This signal you change the variable as minus tau. It is indirectly meaning that you fold the second signal. Fold the second signal. And the third step is shift the second signal. So this signal you shift by t amount. This t may be positive. This t may be greater than 0 or less than 0. This t can be a positive value or less negative value. And the fourth step is multiply signal 1 and signal 2. So these two signals you multiply, that is x of t, h of t minus tau. So here I put a comma, but here there is no comma. It is meaning that they are multiplied. And the fifth step is integrate this multiplied signal over the limit minus infinity to plus infinity. So here first step is x of tau, and the third step up to fourth step you multiply x of tau, h of t minus tau, x of tau, h of t minus tau, then integrate over the limit minus infinity to plus infinity. So this formula can be achieved using these 5 steps, that is change the variables, fold, second one is fold, and the third one is shift, fourth one is multiply, and the fifth one is integrate. So you can remember as CFS MI. You can remember the steps as CFS MI. So we will see the steps, 5 steps. Using these 5 steps, we can achieve what is the value of y of t. Now we will see the step, all 5 steps one by one. Now the first step is to change the variable. X of t is converted into x of tau. The variable is changed as tau. Now again h of t is exponential function. That is a exponential function e power minus at, that is converted into e power minus a tau. Now this is first step, change the variables, and the second step is fold the second signal. So h of tau is the second signal. Second signal you fold, that is a right-handed sequence. Right-hand function is converted into left-handed function, that is h of minus tau. And the third step is shift the second signal. This second signal can be shifted. T greater than 0, that is this side and also this side. This second signal can be shifted towards the right or towards left. Now we will see first one, t less than 0. We are shifting the second signal by an amount of t whose value is less than 0. So this second signal is shifted left side. So this is a third step, shift the second signal. And the fourth step is multiply signal 1 and 2. This is signal 2, shifted signal. These two signals, this one, first signal, and the second signal you multiply. The first signal is available from 0. First signal is available from 0. But the second signal is shifted. It is available from t. So it is present here and it is present here. Both are available in different place. Both are available in different place. So the output value is 0. When we multiply first signal, it is present only this area, and the second signal is present only this area. When we multiply, the answer is 0. So therefore, the output value y of t is 0 for t less than 0. The output value is 0 y of t when time t less than 0. So this is for time less than 0. Again, when t is greater than 0, shift the second signal. For positive time, t is greater than 0. Shift this second signal. This is h of minus tau. This signal is shifted towards right. That is a t positive value. When we shift here, we give the answer like this. We give the function like this. Now multiply 1 and 2. Fourth step, multiply 1 and 2. So when we multiply, this value is a default, it is a step function. When we multiply, this value is 1. So 1 multiplied by anything, that same value, it is e power minus at minus tau. But this signal is available up to the shifted this value. When we multiply this signal and this signal, so the output is available only up to t. So this is the signal. This is the fourth step, multiplied output. And the fifth step is integrate the result. The fifth step is we have the integrate over the limit. So integrate over the limit, minus infinity plus infinity. This function is e power minus a of t minus tau t tau. And of course, by looking this signal, we can conclude this signal is available from 0 to t. So 0 to t, this integration is with respect to tau. So we can take as e power minus a tau, a t outside. So we got the answer. This minus becomes plus e power. So when we integrate this e power minus a tau, the coefficient divided by coefficient, and putting upper and lower limit. Upper limit is t, e power t, and the lower limit is 0, e power 0. The value is 1. Again, when we brought inside e power minus at, this e power plus at cancel, that becomes 1. E power minus at minus 1, that becomes e power minus at. So this value. So output is this value for t for time greater than 0. For time less than 0, as already discussed, y of t value is 0. So output have two values. When time less than 0, the function value is 0. When time greater than 0, the function value is this.